This video is about inequalities that occur in two triangles. Okay, so even though we're talking about inequalities in two triangles, the key is this lesson is really about this thing called the Hinge theorem and the converse of Hinge. Okay, first off, in order for Hinge to take effect, all right, we have to have a side angle side relationship. In other words, we have to have a pair of congruent sides, and then the angles between those congruent sides have to be unequal or not equal to each other. Now, if that occurs, what Hinge tells us is the bigger angle of the two between A and X in this picture, the bigger angle will tell us which side opposite it will be bigger. So if angle A is greater than angle X, then we know that BC will be greater than YZ. Okay? This is known as hinge. Okay? Think of it also, guys, think of like a door hinge. The wider that you open the angle at the door's hinge, the wider the door is open. It's another way to think about it. So it says, right, what inequality relates LN and OQ? So if I look here, I notice I have a pair of sides that are congruent, a second pair of sides that are congruent. So this is setting up the side angle side inequality. And I notice that 125 is bigger than 78. All right, so they want me to compare LN to OQ. And because LN is opposite the bigger angle in the side angle side scenario, I know that LN must be greater than OQ. Simple as that. That's what the Hinge theorem tells me. Typical question that you would look at here would be something you would see on a standardized test. Now I'm going to call this diagram 1 and diagram 2. Okay, and the question says, based on those two scissors, which one of them has the greatest distance between the tips of the two blades? So again, because we're dealing with scissors, we have this side angle side scenario, but the angles in between are not congruent. All right, so based on this, what do we know about the position, about the tips of the two blades? We know that the second one is greater. The second one is greater, and the reason why it is greater is because it's across from the 40-degree angle. Okay? Now, as we see oftentimes, if we have the Hinge theorem, we also now are going to have the converse of Hinge. So if the hinge goes from unequal angles lead to unequal sides, then converse goes from unequal sides create or tell us the order of the angles, which angles are bigger. So in this converse of Hinge, if BC is greater than YZ, then we can conclude that the angle across from BC must be bigger than the angle across from YZ. And that's specifically what they conclude here. All right. I threw this proof in here just for you to look over. It's a unique kind of proof called proof by converse or indirect proof, as high school geometry usually refers to it. Most of the time, you're only going to do indirect proof, though, guys, in college, to be honest. Okay. So a couple of things on this problem. First of all, do we have this side angle side scenario? So we have a side congruent to its side. We have a shared side congruent to itself. And we have a pair of angles in between. This is our side angle side scenario. All right. I look to the sides opposite. I notice the side opposite the 60 is 15. The side opposite the 5x minus 20 is 10. That allows me to write an inequality based on the converse of Hinge. And I can conclude that 5x minus 20 must be less than 60. In other words, 5x minus 20 has to be the smaller angle. But what makes these unique, and the reason why they ask specifically for the range, is because not only does it have to be less than 60, but this 5x minus 20 must also be greater than 0. Why? Because no angle of a triangle can be 0 or less than 0. Now this creates for us a problem to solve known as a compound inequality that you solved in Algebra 1 and again in Algebra 2. So if I solve this inside out, I'm going to add 20 both inside and to both places outside. And that tells me that 20 is less than 5x, which is less than 80. And then divide inside by 5 to get x by itself. So I divide both of the outside pieces by 5, and that tells me that 4 is less than x, which is less than, what would that be, 16. So what are the possible values of x? Somewhere between 4 and 16, non-inclusive. That means not including 4 or 16. All right, let's check another one similar to that. So here again, we have this scenario where we have a side angle side type of relationship. The third sides are unequal, so I know that the angle across from 9 has to be bigger than the angle across from 7. That allows me to write this inequality. Let me use a different flavor here. Let's say that we write the inequality as 3x plus 18 must be less than 90. But, again, because I've got that upper bound, I need a lower bound. And we're going to simply put that 3x plus 18 has to also be greater than 0. Solve inside out. I get negative 18 is less than 3x, which is less than 72. Divide by 3, I get negative 6 is less than x, which would be less than 24. Now this value of x can be anywhere between negative 6 and 24. If x was a negative number, that's still okay because this angle would still be positive. All right, last thing I want to talk about here, all right, is this proof. Now, if you want to, pause the video right now and try to complete the proof on your own. And if you don't want to do that, let me just show you what the proof is and go ahead and freeze this so that you guys can take a look at it and make sure you understand it. All right, let me know if you have any questions.